Have you ever stopped to think about what's really going on inside your computer? I mean, it feels like magic, right? Well, in the next few minutes, we're going to pull back the curtain and decode that magic. We're going to see how a machine actually, well, how it thinks.
Seriously, think about that for a second. You tap a single key on your keyboard, and poof, a letter appears on screen in a literal billionth of a second. What is happening in that tiny sliver of time? It's this incredible journey, this amazing chain reaction of pure logic and electricity. So come on, let's follow that signal and see just where it goes.
All right, to really get how a computer thinks, first we need to understand the language it speaks. And here's the thing, it's not English, it's not Spanish, it's not any language you've ever heard. A computer's native tongue is the language of electricity.
Deep inside your computer, there are billions, and I mean billions, of microscopic little switches. Each one can either be on, which lets electricity flow through, or off, which stops it. That's it. And we give those two states a name. We call on a 1 and off a 0. This ridiculously simple two-state system is the foundation for absolutely everything your computer does.
Now, each one of those individual ones and zeros actually has a name. It's called a bit. It is the smallest, most basic piece of data a computer can even recognize. You can think of it like a single atom in our vast digital universe. Okay, so a single bit by itself, not super useful. But what happens when you group 8 of them together? Well, then you get something called a byte. And a byte, with its 8 slots for ones and zeros, gives you enough unique combinations to represent something we can actually understand, like the letter A, or maybe the number 5. And from the humble byte, the scale just explodes. You've heard all the words: kilobytes, megabytes, gigabytes. These days we're talking about terabytes, even petabytes of information. But what's so incredible, what's so mind-blowing, is that every single one of those massive files is still, at its very core, just a gigantic collection of simple on and off switches.
Okay, so we've got our bits and bytes, but how in the world does that turn into the words and pictures and videos that we see every single day? Well, the secret ingredient, the key, is translation.
So for text, computers use this brilliant standard called ASCII. You can think of it like a universal codebook. For every single letter, number, and symbol you can type, ASCII has a corresponding 8-bit pattern, a unique byte that the computer instantly understands.
So get this. When you type the word hello, your computer doesn't see 5 letters. Nope. It sees 5 totally distinct bytes, 5 very specific patterns of ones and zeros that stand for H-E-L-L-O. This is it. This is that translation from our world to the machine's world happening in real time.
And it's not just for text. Pictures get the exact same treatment. Your screen is made up of millions of tiny little dots called pixels. For any image, the computer just assigns a specific pattern of bits to the color of every single one of those pixels. And the more bits you use for each pixel, the more color combinations you can create, and the more vibrant and realistic that image looks. Okay, so our world, our text, our images, it's all been translated into the language of ones and zeros. But a language needs a thinker, right? Something has to actually process all this information. Well, it's time to meet the brain of the entire operation.
Right there, at the very heart of the computer's main circuit board, what we call the motherboard, sits the central processing unit, or a CPU. If you think of the computer as a symphony orchestra, the CPU is the conductor, telling every single part what to do and when to do it.
Its job is to do pretty much all the heavy lifting. The CPU is the workhorse. It performs all the math, all the comparisons, all the logic that's needed to run your operating system and every single app you use. It's the master calculator.
I'm sure you've heard of the big names that build these brains, right? Companies like Intel and AMD. Now, to make computers think even faster, modern CPUs are built with multiple cores. And you can think of each core as its own separate brain, which allows your computer to handle and process multiple streams of information all at the exact same time.
But look, even the fastest brain in the universe needs a place to work. It needs a desk, if you will, to spread out all the papers it's working on at that moment. For the CPU, that essential workspace is what we call memory. This workspace has a name, RAM, which stands for Random Access Memory. And a really great way to picture it is to imagine a gigantic wall of mailboxes. Every single mailbox has its own unique address, and it holds a little piece of data that the CPU needs right now. And because the CPU knows every address, it can instantly go to any mailbox and grab whatever information it needs whenever it needs it. And this brings us to a really, really important difference. RAM is like your messy, active desktop. It's lightning fast, but it's temporary. The second the power goes off, everything on it gets wiped clean. It's volatile. Your hard drive, on the other hand, that's your filing cabinet. It's a bit slower to access, sure, but it's where everything is stored safely and permanently. It's non-volatile. So let's recap. We have the brain, the CPU, and we have its workspace, RAM. Now it's time to see how they work together. And this isn't just some boring process. It's a constant, blindingly fast digital dance that literally brings your computer to life. This dance is called the machine cycle. The CPU does this 4-step loop over and over and over again, millions, sometimes even billions of times every single second. It is the fundamental heartbeat of all computing. And it all happens in 4 simple steps. First, fetch. The CPU grabs the next instruction from RAM. Second, decode. It figures out what that instruction is telling it to do. Third, execute. It carries out the command. And finally, store. It saves the result of that action back to memory. Fetch, decode, execute, store. Over and over. Billions of times a second. You know, when you take a step back and really think about it, the whole concept is just astounding. We started with a simple on or off switch, a 1 or a 0. And from that one basic idea, we've built this incredible system that can translate our entire world into code, think with a brain, use a workspace, and perform this constant, beautiful, high-speed digital dance. This entire journey, from a simple switch all the way to this complex dance, it really leads to a much bigger question, doesn't it? If we could build all of this from just ones and zeros, what comes next? As we start exploring things like nanotechnology or building computers that use beams of light, are we on the verge of changing how we think about thinking itself?